number 7 asks, without looking at the periodic table, which of these isotope symbols are invalid? 7834 Se, 32.06 sulfur, 1941 K, 65 B. And by not looking at the periodic table, I don't know, maybe these are not the correct atomic numbers or something like that, but I just want to say, is this a valid isotope symbol? And immediately, 2 of them should come to mind as being an issue. First of all, you cannot have a mass number that's a decimal. It has to be a whole number. A mass number is defined as the number of protons and neutrons, which must be a whole number. So you cannot have 32.06. I know where that came from. That came from somebody saying, I don't know what the mass number is, and I'm going to look on the periodic table for sulfur and see that it says 32.06 is the average atomic mass. But that average atomic mass represents the average of billions of atoms, each with different masses. So you cannot use it. When I'm talking about an individual, when I'm writing an isotope symbol, I'm talking about an individual atom. And if I'm talking about an individual atom, I need to know about that specific properties. This would be the same as trying to apply to nursing school and being told, well, since we don't know what your GPA is, we're just going to use the university average of 2.6 and say, okay, so you don't cut it for nursing. So if your average was not 2.6 but much higher, you want to be looked at on your individual merits. So similarly, this sulfur atom needs to be considered based on its number of protons and its number of neutrons, and not based on an average. Also, I immediately see that the potassium has an issue with it. It has a 19 on the top and a 21 on the bottom. A 41 on the bottom. That's an impossibility. The top number, which is the mass number, must be larger because the mass number is the number of protons and the number of neutrons, whereas the bottom number, atomic number, is just the protons. So the top number by necessity must be bigger than the number of protons, and so I cannot have a lower number on the top. So if your symbols are not top heavy, you know you've made a mistake. Then the last problem says write an isotope symbol for a +2 cation with 36 electrons and 48 neutrons. So I need to first, I have electrons, I have neutrons, I need to know the number of protons. I cannot say the number of protons is the same as electrons because this is not an atom, it's a cation. And in a +2 atom, a +2 cation means that it has an extra +2, and the pluses are coming from protons, so it means it has 2 more protons than electrons. And I know that the number of electrons is 36. So I add 2, and I get 38 as the number of protons. So 38 would go in the bottom. I can also look up the symbol for that, and 38 corresponds to strontium. I know it has a charge of +2. I can write its charge here. I just need to find out its mass number. 38 and 48. 16, carry the 1, 86. This is strontium 86 +2 cation.